Okay, I want to look at a couple of applications before you get started on your work. And so I have the first one here. It tells us that a pole tilts toward the sun at an 8-degree angle from the vertical, and it casts a 22-foot shadow. It tells us the angle of elevation from the tip of the shadow to the top of the pole, and that's 43 degrees. We want to find how tall the pole is. So let's see if we can figure this out. If it is, say our sun is over here, it's red and it's hot, and it tells us that the pole is tilting toward the sun at an 8-degree angle from vertical. So if this is the base of the pole and this were vertical, an 8-degree angle might look like that. It's tilting toward the sun, and it tells us that that pole casts a shadow. It casts a 22-foot shadow. So shadows are always on the ground, a 22-foot shadow. And the angle to the top of the pole, the angle of elevation is 43 degrees. Now we have one side, we have one angle, and I think we can find the measure of this angle. If it's 8 degrees toward the sun from vertical, then this angle has to be 98 degrees. 90 degrees plus the 8 degrees. So now we have two angles and we have an included side. So let's call this angle A, angle B, and angle C. Easy for us to find angle C. That's going to be 180 minus the sum of 98 degrees and 43 degrees. And so we find that angle C is 39 degrees. We are trying to find side A. That's the height of the pole. So if we use the information we have with the law of sines, we know that side A over the sine of 43, and of course this is degrees, is going to be equal to side C over the sine of C, which is 39 degrees. If we multiply both sides by the sine of 43 degrees and divide by the sine of 39 degrees, we should see that the height of the pole is approximately 23.84 feet tall. Okay, so the pole is about 23.84 feet tall. Okay, we're going to work a bearing problem. Review what we learned about bearing and how we can find, using the law of sines, maybe the distance of a race course. Here we have the course for a boat race that starts at point A, and it proceeds south 52 degrees west to point B. Now remember what we're doing here. If it proceeds south 52 degrees west from a north-south line, and it's south, not north, we're going to go 52 degrees west, so that's approximately here. That's 52 degrees to point B. And then south 40 degrees east. So if we draw a north-south line and go 40 degrees east, this is 40 degrees east to point C. And it tells us that point C is 8 kilometers, and then it goes back to point A. And point C is 8 kilometers south of point A. So C is directly south of point A. We want to approximate the distance of the course. So let's think about how we might do this. We know that if we started south 52 degrees west, this angle is 52 degrees. And we have parallel lines cut by a transversal. So if this angle is 40 degrees, south 40 degrees east, then this angle, alternate interior angles are congruent. This angle is 40 degrees. And we can also assume that because we have parallel lines cut by a transversal, if this is 52, this is 52. That's 52 degrees. Because I have two sides, or two angles in one side, but to use that one side, I need to know what the third angle is. And if we add 52 degrees and 40 degrees, or we could simply have subtracted from 180, 52 plus 40, or we can use the idea of alternate interior angles. But this turns out to be 88 degrees. So a couple of different ways you could have figured that out. 88 degrees. All right, so if we know that, we need to find side C and we need to find side A if we want to find the total racetrack or the total course, approximate distance of the course. So if we're going to find C, we have C over the sine of 40 is equal to B, which is 8, over the sine of 88. Simply by using our calculator, C equals 8 times the sine of 40 degrees divided by the sine of 88 degrees. And that is approximately 5.15 kilometers. So that's one leg of the course. We've got one leg of the course given, and we can find the third leg of the course again by using the law of sines. A over the sine of 52 degrees is equal to 8 over the sine of 88 degrees. And A equals 8 times the sine of 52 degrees divided by the sine of 88 degrees, which is approximately 6.31. Let me erase that. So if we add those together, we're going to have the total course is 8 kilometers plus 5.15 kilometers plus 6.31 kilometers. 4, 5, and 6 is 11. 19.46 kilometers is the total distance of that race course. I want to begin by finding the formula for the area of an oblique triangle, a non-right triangle. We know from previous classes, previous courses, that the formula for the area of a triangle is half the base times the height. So let's say that we have a non-right triangle. We have triangle A, B, C. We know that side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. Now, I don't have a height, but if I, from angle C, drop a perpendicular to the opposite side, I now have two right triangles, and we'll just call this H. And from our trig identities, we know that the sine of angle B is equal to opposite over hypotenuse, or we could say that H is equal to A times the sine of angle B. We could do the same thing with the sine of angle A. We could say that the sine of angle A is equal to H over B. So in this case, H equals B times the sine of A. And then we could even do a similar operation using the sine of angle C. If we dropped a perpendicular from angle A to side A, we could find the sine of angle C. But if we fill these into the formula for area, area is going to be equal to half the base times the height. In other words, we would have area equals, we could have three different formulas: half of AC times the sine of angle B, or area equals half of BC times the sine of angle A, or area equals 1/2 of AB times the sine of angle C. So it's one of those three forms of that formula that we will use to find the area of a triangle. So let's say that we wanted to find the area of a triangular lot with two sides measuring 90 meters and 52 meters, and an included angle of 102 degrees. Well, we can just simply plug into the formula. Area is going to be equal to 1/2 of 90 times 52 times the sine of 102, and simply plug that into the calculator, and when we do, we should get the area is approximately 2,289 meters squared. Notice in our formula it is two sides, C and A, and an included angle. Or if we did side B and C, we use the included angle. If we did side B and C, we use the included angle A. Or if you use side A and B, you use the included angle C. But the formula is easy to apply. Just be sure that your calculator is in degree mode.